Okay, let's take a couple examples and let's sort of talk about how we do this stuff. Is there one, can I give you a magic recipe for solving word problems? No, there isn't one, right? Every word problem is a little different than the others, right? They're all going to take a slightly different approach, but there are some common themes and strategies that always pay off, and that's what we're going to talk about. So the first thing is you got to read the question more than once. You got to read it once to kind of just get an overall feel and then read it again for detail. Okay, so we can do that. The product of 7 and a number increased by 3 is twice the number subtracted from 39. Find the number. That's a lot of math words. That sounds confusing. So you definitely have to go back and take that piece by piece, right? Okay, we'll do that. We're gonna dissect this thing in detail here in a second. Okay, next thing is you probably want to ask yourself, well, what are you trying to find, right? What is it that we're looking for? In this case, what is it? What are we trying to find here? A number, right? Some number. It's unknown though, right? We don't know what it is. And so what are we probably going to call that number? Yeah, that's the unknown. Unknown equates to variable, doesn't it? Right? So it's the unknown. The unknown should be, in this case, it's not that big a deal, but the unknown should be the thing that we know nothing about that we're trying to find. In this case, pretty clearly, that unknown is the number, so we're going to call that x. Okay, the next step is, can we take that sentence and can we translate that into a math sentence that we can solve, meaning an equation? There are some words that we look for that are just that help us out, that are giveaways. For example, here's one I bet you're familiar with. When you see is in a word problem, what's that going to become in the equation? That's going to be, well, I think I heard it. What is, someone want to, equals. Yeah, is or was, stuff like that. Those state of being verbs like that, those are almost always going to be equals, right? So we've got this equal sign then. Now we got to know what's equal to what in our equation. So let's see, we got to figure out what's on the left side and the right side of that equal sign. Let's take everything on, let's take this sentence right here. The product of 7 and a number, okay, how am I going to say that first of all? 7x, right? Product means multiply. So that looks an awful lot like a 7x increased by 3 plus 3 is, so equals. Okay, there we go. 7x plus 3 equals twice the number, 2x. Everybody agree? 2x. Okay, you got to be careful with this one. Subtracted from 39. So what's that whole expression going to look like? Is it, give me thumbs on that. Thumbs up if you agree, thumbs down if you don't. 2x minus 39. Oh, what do you think? It's got to be 39 minus 2x because we're subtracting from 39, right? So there we have it. Okay. Give me 1 to 5 on that. Okay. Would you agree from here on out, this is just piece of cake, right? There's nothing much to do here. We'll push all the x's to one side. Let's kind of just breeze through this algebra real quick. Where am I pushing the x's, left or right? Left. How many am I going to end up with on the left side when I do that? 9x. I'm going to add 2x to that side. So 9x plus 3 equals 39. What would the last two steps be in order to solve for x? Subtract 3 and then divide by 9 in that order. Very good. Okay, do that in your head. Mental math makes you, it's like lifting weights for your brain. Try that. See if you can come up with that in your head. What'd you get? You can just show me with fingers if you want to just check it out. Yeah, I'm seeing it. We get x equals 4, don't we? 36 divided by 9 gives us 4. Okay, is that my answer? When we're solving an algebra problem, when we get x equals a number, we circle it and move on. Can we be guaranteed that that's the right answer to this? Okay, so we always have to go back and say, okay, now what is so I know the value of x is, what's this? Value of x is 4. What are they asking for? The number, which is, okay, so it is 4 this time, right? The number is 4. X was the answer, but it may not always be. You always have to check that. So there's our answer. There's the number. Let's try another one. How about this one? Kara's golf score was 1 less than 3/4 of Greg's golf score. If the sum of their scores was 153, find Kara's golf score. Okay. All right. What's sum mean, by the way? Addition. Okay. This is a little tougher because this time there's 2 scores involved, right? There's Kara's golf score and Greg's golf score. So how are we going to deal with that? There's 2 things that are unknown here, right? I mean, I guess we could say, let's let Kara's golf score equal X and Greg's golf score equal Y, right? Okay, what's the problem with that? We could make that work, but you're kind of headed down a slippery slope when you do that. When we introduce 2 variables, as we're going to talk about later in the year, the fundamental theorem of algebra says we have to have a system with at least as many equations as we have unknowns. So the second I start to do x's and y's, this starts to get a little bit uglier. Now I've got a system that needs 2 equations I've got to solve in my system. It doesn't sound good. It's doable, and we'll review that stuff later. But we'd rather not do that. We'd rather just have a single variable if we could. And then I only need 1 equation. That's easier, right? Okay, but here's the deal. I've got 2 scores that I don't know about. The rule is, and this is one you bank, this always is very helpful when you're doing word problems. When you want to assign the variable, you want to set the variable equal to the thing you know nothing about. Now, I would claim that we know something about one of those 2 persons' scores. May not be much, but we know something about one of their 2 scores. One of them we know nothing about. Whose do we know nothing about, Kara's or Greg's? Greg's, right? We know Kara's golf score was 1 less than 3. Well, that's telling us something about hers, isn't it? Right? So hers we know something about compared to his. His we know nothing about. So we're going to let Greg's golf score equal X because that's the thing we know nothing about. Okay. Now, ultimately, what we're trying to set up here is an equation. It's the second sentence that really gives us the equation, isn't it? Tells us the sum of their scores was 153. You already told me that sum means addition. So I've got to be able to add up Greg's score and Kara's score to solve that equation. Well, if we're going to say that Greg's score is equal to X, and let's kind of color code this. So Greg's golf score is the blue X. What's Kara's golf score going to be? Tells us Kara's golf score was 1 less than 3/4 of Greg's. Okay, but it doesn't say 3/4 of the sum. It says it was 1 less than 3/4 of Greg's golf score. What is Greg's golf score in our problem now? That's X, isn't it? That's our unknown. How could I say that then? How could I say that red sentence? 1 less than 3/4 of X, because that's Greg's golf score. There you go, right? Couldn't I just do that? 3/4 times X. When we see the word of, that means times. Almost always that means multiplication. So 3/4 of X minus 1. There's our 2 scores, agreed? So the sum of those 2 has to equal 153. Well, that's no big deal. We're just adding them up, right? We just get 3/4 X minus 1 plus X. The combination, the sum of the 2 scores equals 153. I can just solve that now, right? No big deal. We got it set up. Give me 1 to 5 on that. Does that make sense? Okay. Okay. Good. Good. We need a little more practice. We're getting where we need to be, but just takes a few examples. How about one like this? The sum of 3 consecutive odd integers is 93. Find the integers. Okay, well, first of all, let's figure out what that's asking us, right? We have to know that vocabulary. We have to understand what that means when they talk about consecutive odd integers. What's an integer? We should know this. We talked about that before roundup. Say it again. Okay, it's very closely related. The set of integers includes the set of whole numbers, but it has something else that whole numbers doesn't have. Negatives, right. So the set of whole numbers would be, think of it as the hash marks on a number line. It's all of the positive and negative numbers and zero that can be written with no decimals, right? They're just a number with no decimal places at all, okay? Other way to think about it is, as a fraction, they simplify to a fraction with a 1 on the bottom. So then give me an example of just 3 consecutive odd integers, somebody. What does that mean? 3 consecutive odd integers. Say it again. Like 1, 3, 5, right? So odd integers are just odd numbers, aren't they? Right? And consecutive means in a row. Okay, so we have to find a sum of 3 consecutive odd integers that adds up to 93. Okay, now we've got these 3 integers. The first integer, the second, and the third in order, right? Which one of those 3 do I know nothing about? Because I would claim 2 of them I know something about. The first one. Yeah, the first one we know nothing about. Let's call that x. Okay, if we do that, if we call the first integer x, then what do I know about the second odd integer? How much bigger is it than the first one? Isn't it? I mean, don't we just always, odd integers are always going to be 2 apart, aren't they? 1, 3, 5, 11, 13, 15, right? So how would I write out the expression that represents the second odd integer? X plus 2. So I do know something about it. I know it's 2 bigger than the first one. And then what's the third one going to be by extension? Yeah. Okay, now this isn't so bad, is it? The sum of those 3 integers means adding them up. So if I add all those up, it should equal 93. Okay, so we can do that. The sum of the 3 integers is 93, right? Okay, well, what's that look like then? We got, I guess I did that in blue, didn't I? Just for the note purposes, I want to make sure I get this all, the colors all right. So you can look back at the colors and they mean something. So the sum of 3 odd integers, that's the blue part, that's whatever that color is, 93. Make sense? Okay, and that's not a tough thing to do. If I add all those like terms up, how many x's do I have? 3 x's, so 3x plus 6 equals 93. Do that in your head. It's a little tougher, but this is do a quick set of brain push-ups. Anybody want to be brave? You got an answer? What do you think? No? Oh, yeah, you added. That's all you did. Okay, so you can get it then. 29 is it. There you go. So it's 29. Yeah, if we just keep going, we'd subtract 6, divide 87 by 3, and that's 29, right? How could you do that in your head? 87 divided by 3. Do you even know, I guess, is 87 divisible by 3? It must be. How would you know it is, though? There's a good little trick to know. Say it again. No. No, a number divisible by 3 could end in any digit. That's not it, but it has to do with the digits. Okay, here's the trick. If you add up the digits of a number, so 8 plus 7 is 15. If the sum of the digits is divisible by 3, then the number is also. How about that one? So 8 plus 7 equals 15. 15 is definitely divisible by 3, isn't it? So 87 must be. Okay. What could you do then? Well, 7 goes into, or 3 goes into 8 how many times? 2 with 2 left over, doesn't it? Right? So we're going to get 20 something. If I carry that 2 up there, 3 goes into 27 9 times, 29. Okay, makes sense? Okay. All right, so we get 29. We're done. X equals 29. We can move on, right? Good? Is it? If I just put 27 down for my answer, am I going to be right? No, it says find all the integers. Didn't say find X. It said find the integers. Well, what are the integers then? So X we said was 29, right? So what are the integers then? 29, 29 plus 2, and 29, 29 plus 3, or plus 4, sorry. So those three numbers, right? Okay. 1 to 5, how we doing? Okay. Ooh, we're climbing up there. That's good. We're climbing. Okay, how about this guy? The measure of the vertex angle in an isosceles triangle is 6 less than 4 times the measure of a base angle. Find the measure of the angles, blah, blah, blah. That's a lot of math. A lot of math coming at you there. So we got to read that again. The measure of the vertex angle in an isosceles triangle. Well, let's stop there. We got to, first of all, what the heck's an isosceles triangle? What makes a triangle isosceles? Okay, it's got two congruent sides, good, and what else is true? If it's got two congruent sides, what else do you know? Same length, okay? Say it again. Well, okay, 90, if it has a 90, that'd be a right triangle, right? What else do we know about the angles in an isosceles triangle? Say it again. There's two of them are also congruent, right? We got two sides of the same length, and the opposite angles are also congruent. So in this case, those would be these angles down here. Those are what we call the base angles. Okay, the vertex angle is the one oddball angle that's different. So here's one thing we know. Those two angles, the base angles, are congruent. Okay, same angles. Okay, so let's try this again then. The measure of the vertex angle, so that's this guy, right? In an isosceles triangle is 6 less than 4 times the measure of a base angle. Okay, which of those two types of angles, base angle or vertex angle, do we know nothing about? Because one of them we know something about. Vertex we know nothing about. Okay, I'm hearing both, base angle and vertex angle. Let's take a vote. We'll make this a democracy in here. How many people are going to say thumbs up for base angle or thumbs down? Okay. Okay. How about vertex angle? Voted for both? Well, let's try it. The measure of a vertex angle in an isosceles triangle is 6 less than, well, hold it. It's telling me something about the vertex angle. I must know something about that. Is 6 less than 4 times the measure of the base angle? Do I know anything about the base angle? Nothing, right? So that's going to be my unknown. Agreed? Everybody get that? Give me thumbs on that idea, right? You see why it's the base angle that we want to call x here. Because we know something about the vertex angle in terms of the base angle, right? Just like in the last example, the second integer was x plus 2. Well, we know something about it. We know it's 2 bigger than the first one, right? We know nothing about the first one. So right away, we know that. We know nothing about the base angle, so we're going to call the measure of a base angle whatever we want to. Let's call it x. So that goes there and there, right? Okay, then what about the other part? So if the measure of the base angle, that's x, what about the measure of the vertex angle in an isosceles triangle if it's 6 less than 4 times the measure of the base angle, which we can just call x now. If you call it x, it makes it easier. How do we say 6 less than 4 times x? 4x minus 6, right? Okay, we good? And I could plug in that number right or that value up here, 4x minus 6, and now it wants us to find the measure of the angles. Well, what the heck? There's no equation that's given to us. So there must be some geometry property that we can draw on here to make an equation. What is that? What do you think? Yes. Equals, is it 90? Oh, 180. There you go. That's okay. It's the right idea. It's 180, isn't it? The sum of the interior angles in every triangle is always equal to 180, isn't it? So yeah, we can set this up then as, whoops, 4x minus 6 plus x equals 180. And that's a pretty easy equation to solve again, isn't it? If we add up all the like terms, that's just giving me 4x plus x plus x, that's 6x, minus 6 equals 180. Go. Try that. Double dog dare you. Quick as you can. Find x. Mental math. That's it. 31. You got it. 31. If I add the 6 to this side, I get 6x equals 186. 186 divided by 6. Isn't that just 31? So again, am I done? No. We got to go up here and it wants to know, find the measures of the angles. Okay. So, well, x is 31. So I know 2 of them, right? This one is 31 degrees. This one is 31 degrees. How would I find the top one? Yeah, good. I've got to just plug in my x, right, which is 31. So the top one is going to be 4 times 31 minus 6. Okay, quick, some more mental math. What's that? 118. Hey, we're getting better. I can see the wheels turn. A lot of people probably were right there. So that top one, 118 degrees, and we got it. How could I quickly check my answer? Yeah, add them up. They got to add up to 180, don't they? Right? Okay. One more, and we're calling her quits. And you guys, we're ahead enough that I think tomorrow you guys will probably just get a work day on this. Okay, because we won't have to probably do any more examples. How about this one? The length of a rectangular mural is 1 foot longer than twice the width. The mural has a perimeter of 56 feet. Okay. Find the dimensions of the mural. It might even help to just draw a little picture. Okay. So we know there's 2 things that we don't know here, right? We don't know the length and the width. Which one of those things do we know nothing about? The width. Yeah, good. The width we know nothing about. So the width we'll call x. So how do we say this then? The length of a rectangular mural is 1 foot longer than twice the width. Everybody agree? 2x plus 1, 1 more than twice x. The width is x. So don't we get something like this then? 2x plus 1 is the length, the width is x, and the whole perimeter is what? 56. How do you calculate perimeter? Okay, add up all the sides. So I'm adding up 2 of the widths and 2 of the lengths. Agreed? Okay, so then wouldn't I just get something like this? 2 times length plus 2 times width equals perimeter, which is 56 feet. So 2 times my 2x plus 1, which is the length, plus 2 times x, which is my width, equals 56, right? Is that tough? Once we get there, we flip into algebra mode, and this is a piece of cake. If I distribute the 2, what am I getting here? Julia, if I distribute that 2, what do I get? Multiplying that 2 all the way through. Oh, is that too far back? Okay, I'll somebody else then. Oh, there you go. Okay, good. Okay, good. 4x plus 2, good. Plus 2x is just, 2 times x is just 2x, right? Equals 56, combine like terms. 4x plus 2x is 6x, plus 2 equals 56. You know what I'm going to say. Go. Solve it in your head. What'd you get? 9, good. Ellie's getting fast at this. Just that little bit of practice already, she's tearing it up. Divide by 6 and we get x equals 9. We circle it and we're done. No, not necessarily. We got to go back and see what they're asking for. They want the dimensions. Okay, if x is 9, that's the width. What's the length? What do you think? What's the length? 19, yeah. 2 times 9 plus 1, that gives us 19, doesn't it? There you go. 19 feet by 9 feet, that's our mural. Okay, give me thumbs. Good? All right, I'm going to turn you loose, work on this a little bit. I'll make it available.